All right, guys, so let me go over some box and whisker plots with you. So the very first thing you need to do when you have your data is put them in numerical order. So my data is already in numerical order, but it won't always be. So always check that first. So box and whisker plots basically divide your data into quarters. So I'll show you what that means in just a second. So first of all, let's count how many numbers are in our data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the very first thing you're going to do is find the median. So if you have an odd set of data, you're going to have one middle number. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the first thing we've identified is the median. Now, obviously, if there's an even set of data, you're going to have two middle numbers. For example, let's say our data looks like this. 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. All right, so if you have an even set of data, what you're going to do is just draw a line through those two middle numbers. You'll have 4 lower numbers and 4 higher numbers. But since I have an odd set of data, I went ahead and just, boxed in my middle number, and I still have the same amount of digits on both sides of my median. So that's a good tip for you guys to remember. All right, so once we have figured out our middle number, now our lower quartile, also called quartile 1, those mean the exact same thing, is the median of our lower digits. So the middle number of our lower digits is 75, and the median of our higher digits is 85. So this is our lower quartile, also called quartile 1. This is our upper quartile, also called quartile 3, and the median can be called your quartile number 2. Okay? So what is our upper quartile? The upper quartile is quartile 3. I'm sorry. Let me change that. Upper quartile is quartile 3. So what is it? It is 85. The lower quartile, which is quartile 1, is 75. All right. So these are just new vocabulary words. You're going to just have to memorize them. So if I have an even set of data over here, so I really have 2 middle numbers in my lower digits. Well, what comes between 4 and 4? Well, it's 4, right? What about my upper numbers? What's the middle? Well, the middle comes between 8 and 10. So what comes halfway between 8 and 10? 9. Or in other words, if I add 8 plus 10 together and I divide by 2, I get 9. So in this situation, 4 would be quartile 1. And 9 would be quartile 3, and our median would actually be 6, or our quartile number 2. All right, so then these next 2 numbers, or words, excuse me, they're pretty self-explanatory. The minimum, the smallest number, is 60, and our biggest number over here is 88. All right, so once you have your data, now you can make your box and whisker plot. However, 2 other words that you're going to need to know is the range of your whole set of data and then the interquartile range. So the range, you use all your digits, you take this biggest number, and from it you subtract your smallest number, and the range of the data is 28. The interquartile range, however, we take quartile 3 and subtract from it quartile 1. So our upper quartile minus our lower quartile. So our interquartile range is 10. Okay. All right. So let me erase some of this, and we're going to make our box and whisker plot. All right. So a lot of people will make the mistake of using their data as their number line. This is not a number line. This is your data. You have to make a number line. So like all number lines, you have to count consistently and you cannot skip digits. So we know our number line has to be from at least 60 through at least 88. So you decide, what are we going to number by? Are we going to number by 1s or 2s or 10s, whatever whatever works for your data. So I think I'm going to go ahead and number by twos. Whoops, 70, 72, 74. Uh-oh, mine's a little bit too short. There we go. All right, so for our interquartile, our box and whisker plot, we need to label all of these numbers right here. So your box goes from your lower quartile, quartile 1 to quartile 3. So quartile 1 is 75. So I'm going to make a little line right here. This is going to be the left side of my box. My quartile 3 is the right side of the box up here at 85. And then you're going to complete your box. The line in the box points toward your median. So 79 is our median. Our whiskers is a box and whisker plot, right? So our whiskers point to our minimum and our maximum numbers. So a box and whisker plot, like I said, it divides your data into quarters. So the whisker represents 25% of your data. From here to here, it represents 25% of your data. From here to here, that's 25% of your data. And your right whisker represents 25% of your data. So you could say the highest 25% of my data goes from 85 to 88. The highest 25% of my data. You could say the middle 50% of my data ranges from 75 to 85, which of course the interquartile range is 10, so that makes sense. We could say the lowest 25% of our data is between 60 and 75. The lowest 25% of our data is from 60 to 75. All right, I had to change locations. So anyway, we're going to move on. So here obviously is a double box and whisker plot. So what they're doing here is they're comparing the heights of girls and boys in inches. So with box and whisker plots, the more spread out your box and whisker plot is, the more varied your data is, okay? The smaller your box and whisker plot is, the shorter it is, the more condensed your data is. So for example, look at the girls' heights. The girls' heights range between 64 inches and 70 inches. Well, that's only a range of 6 inches, right? The boys, however, their heights range from 61 inches up to 73 inches. So that means their data is much more spread out. The girls' heights are closer together. The boys, there's a large distance between the tallest guy on the team or the class and the shortest guy. So their data is more varied, okay? All right, so it says describe the distribution of the data. So like I said, based on our double box and whisker plot, the girls' heights are more consistent and the boys' heights are more varied. For each test, identify the this would be heights. For each graph, identify the minimum. So what's the minimum for the girls? So the shortest girl is 64 inches. The shortest guy is 61 inches. What is the lower quartile or the quartile 1? So the quartile number 1 for girls is 66. So that means 25% of our girls are between 64 and 66 inches. So there's only 2 inches that separate those 24, the shortest 25% of our girls. There's only a difference of 2 inches there. All right, what about the boys? So the lower quartile of the boys is 65, or the quartile 1. And then the median, the middle girl's height is 67. The median for the guys is 66. So the middle girl is actually is 1 inch taller than the middle guy, which is kind of interesting. And then our third quartile for our girl is 69. For our guy, it's 70. So remember, 25%. So 25% of our guys are between 66 and 70 inches, right? 25% of our guys are between 65 and 66 inches. That's only 1 inch difference. And then of course our tallest girl, the maximum girl, is 70 inches tall, but our tallest guy is 73 inches tall. All right, hopefully you guys could pause the video and answer those before I answer them. All right, so it says using the given double box and whisker plot, so the same data here, determine the percent of boys and then the percent of girls who are 66 inches or shorter. So the percent of girls that are 66 inches or shorter is 25. So our girls, 25% of our girls are 66 inches or shorter. And for our guys from here to here, this represents 25 plus 25. So our guys, 50%, half of our boys are 66 inches or shorter. Okay, half of our guys, but only 25% of our girls. All right, let's look at this. We have math test scores of tests that were taken in the afternoon, much more varied than the scores of students who took their math test in the morning. Much shorter box and whisker plot, which means their scores were much more consistent, and it looks like overall much higher, because almost, I mean, these differ a little bit right here, but I would say that, you know, it's almost like the lowest 25% of the grades in the morning was almost about 75% of the afternoon's grades, right? So it says it's thought that taking math tests in the morning results in higher grades than taking math tests in the afternoon. Do the data represented in the box plots below confirm or above confirm this hypothesis or not? So I would say yes, the data does confirm this hypothesis, because the lowest score in the morning was 72.5. However, the lowest score in the afternoon was 55. The highest score in the morning was higher than the highest score in the afternoon, and their grades were much more varied than in the morning. Like 50% of the kids in the morning scored between a 72.5 and about, I don't know, what would that be, about 93, okay? So I would say yes, it confirms that hypothesis. All right, it says given, so here we have score by 2 clubs. So club 1 and club 2, whatever they were playing, they were giving scores. Given the double box and whisker plot, which club has a higher interquartile range? So remember that interquartile range is the difference between quartile 3 and quartile 1. Quartile 3 and quartile 1. So this interquartile range is 60 minus 30. So they had a 30 interquartile range. For club 2, they had 60 minus 20. So they had the bigger interquartile range. Which club had the higher interquartile range? It was club 2. Club 2. All right, guys, that's it. So you'll have a few questions to answer for today, just to confirm that you saw these videos and you're understanding box and whisker plots. You know what median is, you know what lower quartile or quartile 1 is, the quartile 3, the maximum, the minimum, how to find the range, how to find the interquartile range, and make sure you always number your data numerically. You always put it in numerical order, just like you had to last week when you were finding the median. Remember, you always have to have that data in numerical order first. All right, if you guys need me, let me know, and I hope everyone has a great week. I'll see you guys later.